We just talked at sort of the bigger picture level and a little bit forward-looking. The point of this panel is to really drill down into the, into some of the specific mission use cases. And I'm delighted to have our two panelists here today. We have Ralph Quinn Palmer with Customs and Border Protection. He's Assistant Chief and leads CBP's Small UAS program. Sir, thank you for being here today. And then, I realize I can't see you, so sight lines be damned. No, that was me. You're good. And then Major Michael O'Connor with U.S. Space Force. And Michael's here wearing sort of two hats, both the work that he's doing with the Space Force and right now serving as an Air Force Fellow at Georgetown Center for Security and Emerging Technologies, thinking about some of these issues and about the network, the data, the comm side of things, but also, in your Air Force days, we're testing some of these devices, and so there's a couple different perspectives we can bring. So first of all, thank you for being here and sharing your time and your expertise. But I gave basically just names and titles. I'd like to give each of you the opportunity to just talk a little bit about the work you do and how it fits in today's conversation. And Michael, let's start with you on that.
Yeah, certainly. So to give a little bit of background on me, so thanks for the introduction and thanks for having me here. So I started my career education-wise in aeronautics and astronautics. There was a lot more space in that than in the air domain. Did space acquisition, got the opportunity to go to the Air Force Test Pilot School, followed that up with a remotely piloted aircraft flight test assignment. So really got to dive into the unmanned and unpiloted space, well, remotely piloted space. Have since gone back into the space community, transitioned over to the Space Force, where I continued to do test and evaluation. Some of the themes that you see from the air domain, some of the themes you see us talking about today, you see a lot of those same things in the space domain, right? There's proliferation, there's a whole lot more data, a whole lot more communication. And so that's what I'll be talking about today. And then at Georgetown's CSET, I also get the chance to see, how does AI work into things? How are these emerging technologies influencing security?
Right, yeah, thank you for mentioning that. I neglected the data and the AI part of the puzzle, and which I think has been a big part of your work and thinking. So, very good. And thank you. Quinn, same question to you. Talk a little bit about, CBT is sort of the secret superpower in the use of unmanned systems in the U.S.
Sure. Thank you for the invitation today. Good morning, everybody. My name is Quinn Palmer. I'm 24 years in the U.S. Border Patrol. But Border Patrol is executive agent for all of CBP. It's a component within CBP, a little bit about CBP. Customs and Border Protection. One of the components, so we're the executive agent for all of CBP. We're the most prolific user within the agency of small unmanned aircraft systems. We have about 500 assets operationalized throughout the United States. We have about 2,000 operators trained, certified. And CBP responsible for border security, but also the regulating and facilitating legitimate trade and travel into the United States at all air, sea, and airports of entry. So our operational domain, if you will, our environments cover the gambit of the continental United States, 13,000 miles of linear land border, double that, coastal maritime environments. We piloted small UAS as an agency, tacitly in 15, but really first couple of assets were procured and testing began in earnest in 17. Obviously, GOTS systems in partnership with some of our DoD partners. And we've since grown, so it went from 5 years ago to 500. We're nearing our full operational capability in terms of inventory size. Finding every day, different use cases, mission sets.
And when you say full operational capability, based on the current plans, based on the capacity you have of personnel or budget, sort of what's setting that cap? Because I would imagine the actual mission needs could probably expand to fill all available capability.
Absolutely, that's a very good question. So we base our full operational capability based on, it's an acquisition plan language, but it's based on the operational requirement as defined by the different field locations.
Okay.
And that fluctuates. Right? And as the capability fluctuates, it'll translate into a different assortment of what and where needs to be deployed when. So.
Very good. And talk a little bit about the mission use cases that went into determining that that operational capability and capacity. Clearly, ISR and surveillance is part of it, but I suspect there's probably some ways they're being used that we might not think of top of mind.
Absolutely, ISR is the bread and butter. Obviously, Border Patrol being the more prolific user within CBP, we have about 3 drones flying at any minute of any day. So, and it doesn't sound like much, but when you think about most of our drones only fly for 30 minutes, we're putting some mileage on them. And that is the ISR mission, the detection, classification, identification of folks coming illegally into the United States or smuggling contraband into the United States. But we also have a significant trade mission, and we see utility in the future, with different type of sensor arrays that maybe become isotope or radiation sniffers. We're utilizing it for national disasters, obviously providing situational awareness as a response agency, mapping. We make better training products with drones. So we've got them at every niche and corner within the agency, and again, they're being developed every day.
And one of the broader use cases for these small UAS is sort of inspection, particularly of infrastructure. And there's a whole lot of infrastructure that your organization is focused on. Is that part of the current use case, or is it on the drawing board?
It's actually I did not mention that, but it's actually one of our growing facets to how we deploy the time savings and the safety associated with our tower climbers.
Right.
It's become a very significant piece of potential future investments.
Okay, and with both that and the core ISR mission, are you still working in the one-to-one operator to device, or are you starting to move into more of the one-to-many and the different command and control that involves?
That's a complicated question.
Yeah.
But I'm trying. This is as simple as I can. So it's dependent, right? I see the one-to-many really is requiring more of a system of systems infrastructure, which we currently do not field for various reasons. But the one-to-one works for us. And I was listening to the conversation, hard act to follow, by the way, the gentleman you had up here just a minute ago. I was listening, and he made a very salient point, and that I would foot stomp. So if I buy a $1 million system that requires a $1 million piece of infrastructure to be able to fly BVLOS, first of all, we're domestic, so we have a completely different set of issues and constraints and guardrails than in military theater of operations.
And a completely different number of zeros on the budgets.
Yeah, so versus, I get the same coverage, at 1/50th the cost with smalls. It is more manpower intensive, so I need more operators to fly more smalls, obviously. However, I've got people out there anyway in those locations. They're coordinating with the guy or the girl to the right or to their left. There's magic that happens when the team is integrated to that extent, and you're offering up this new capability. We use SUAS not necessarily as a detection capability. I know I mentioned that earlier, but it's more of a response capability. So we've got a detection. We've got a sensor alert from somewhere in our laydown, and we're responding. We're using that as Overwatch. We're using our ISR basically as Overwatch for officer safety reasons.
Okay. And Michael, let's kind of go back to your flight testing days when you were helping test some of these remotely piloted systems.
Let me back up.
Yeah, it's okay.
I feel like
Just don't back off the back of the stage. Yeah. That would be bad. What were the key use cases you were testing for, or what were the missions you were trying to work against?
Certainly. So, right, I can only talk from my personal experience, and right, I'm not officially speaking for the Air
absolutely.
Force, all that. But what I saw was, just like Quinn said, it's primarily intelligence, surveillance, reconnaissance. It's ISR. It's understanding the laydown of what's out there. Now, you've got you can run the gamut of different systems, all the way from the tactical, which gets a lot of news in Ukraine, all the way to the operational and potentially into strategic with things like the Global Hawk and the partner versions of that. So ISR is a very big part of that mission. Now, moving into the future, right, that's still going to be, I think, the bread and butter, right? All the videos you see coming out of Ukraine, the real exciting ones that get all the hits, get all the views are much more kinetic. But the ISR is really the fundamental part there. And then, right, we'd kind of be remiss if we didn't say, okay, if EW is such a major player in Ukraine, I mean, someone smart is going to put that on a remotely piloted aircraft or some sort of a vehicle and make it a whole lot more mobile. So those are kind of the themes I see going forward.
Okay. And this is a question for both of you. In Peter's talk earlier, he mentioned the different paths as we explore his mission. There's the extend your reach. There's the the kind of like co-pilot or wingman model. There's the agent model, and there's one that I admit I'm forgetting at this point. But it seems like certainly with CBP, most of it is the extend the reach of the operator right now. Is that a fair characterization, or are you all seeing those different those different paths of how to develop mission applications for these systems coming together?
Yeah, if you're talking about endurance, yes, I want a lighter, smaller, longer-lasting battery. That's what if we're talking about. But if we're talking about extend the reach in terms of what the capability provides,
I mean, extend the reach
mission
that Border Patrol agent can now be seeing in places that she or he couldn't easily get to as quickly.
Oh, absolutely. The efficiency of the mission,
yes.
of exercising, executing the mission, absolutely. I mean, that was the one thing that we learned very quickly. Obviously, the impetus behind our engagement with the small UAS pilot program was to kind of cover that delta that manned aviation was not able to cover. That it can't be everywhere. There just aren't enough manned aviation assets or pilots. And so in doing that, we also very quickly discovered, wow, in very specific situations, they're so much more effective because of the covertness, the nature of the drone themselves. I mean, you hear helicopters coming 5 miles away. If you're trying to get away from the authorities, you're going to begin your plan to escape a lot sooner. But when you're being surveilled and we get to initiate, if you will, that first contact, we sustain that initiative. Not only is it safer for our folks that are potentially walking into a violent confrontation, but if it's 20 folks, now you pick the time and the place of that first contact, and now you've got that group wrapped up versus now I've got to chase down 6 that went east and 5 that went west and 6, and then what would take 5 hours to locate 20 people trying to abscond from you really only takes that first 10 minutes of initial contact. That's an efficiency that translates into real dollars, labor costs. So yeah, no, that's something we learned very quickly, if that answers your question.
Yeah, absolutely. Michael, your take on?
Absolutely. So it is an efficiency issue, right? There's certain performance that you're going to get out of a piloted pilot in the seat, in the air vehicle. Those vehicles are going to be larger. They're going to have more power. They can carry bigger payloads. They can get better performance. But that pilot is only going to be able to sustain being up there for so many hours. They can gas up. They can refuel. But again, that's just going to extend until your pilot's just done.
Yeah.
It's a whole lot easier to do crew swaps on the ground at 1G zero airspeed. And so you do get those efficiencies, right? If a Global Hawk can be up for more than a day and you don't have to take it off of station, it can constantly be looking. You can cover a whole lot more ground. right? You're not going to get the performance out of the vehicle, right? It's not going to have as much power. It's not going to, it's certainly not armed, but you're going to get that efficiency trade-off, right? All of this is about, how do you want to dial the knob?
Right, right. And we will absolutely come back to the the hardware efficiency questions and some of the constraints there in a minute. But Michael, sort of going back to the work you're doing for Space Force now, it's safe to say that a fair amount of the focus is on the AI enablement and the communications networks that are needed to allow for more effective command and control. And I'm just kind of curious, what do you see as like the most striking development in as both the technologies and the ways of thinking about using them have evolved over the last couple of years?
I think it's a recognition of the sheer quantity of platforms, of systems that you have to interface with and integrate all together is really the game changer, right? Starlink has, I think, as of today, more than 4,000 satellites on orbit, right? It would be incredibly expensive, and I can't imagine the coordination of having 4,000 people trying to talk to each other to just do some simple things as collision avoidance, orbit maintenance. So that gets automated. On the DoD side, right, we are still buying, in general, larger, more exquisite platforms, but the Space Development Agency, SDA, is certainly moving away from that. And so I can see, as an outsider looking in, you're probably going to get a lot more of that same integration effort. And then just anything the Space Force is doing to become a more resilient force, to become more operational, right? A lot of that is going to be what planning can you automate? Where's the smart applications of people, right? Our force as of a year ago was capped at 8,300. I think we're still under 10,000. We're smaller than the Coast Guard, probably smaller than Border Patrol even, although I don't know your exact numbers. It's a very small force, and so at some point, we're going to have more satellites than people, and so you need to have the computation, you need to have the automation and integration to be able to handle that workload. And the jobs are certainly not getting any simpler.
Right. Okay. And Quinn, how does that square with what you're seeing at CBP? And I'm sorry, that being, this use of AI and automation to, to kind of help deal with what might otherwise be a logjam and not enough humans.
It's about 20,000, to answer your question. A little bit, maybe, I don't know. I'm split on this. I think there's a balance to be struck, but it depends. To me, it depends on what we're actually specifically talking about. I mean, we talking about fleet monitoring, fleet management system, those less flashy aspects of it. Absolutely. I mentioned a little bit ago, integrating to systems, there's a cost burden associated to that right now, given the environments that we operate in. I mean, a lot of the capacity type infrastructure that we would need to facilitate that type of, it's just, there's no commercial interest.
Right.
So, but and also in the law enforcement, and so we don't want to bite the AI ML elephant in one swallow, right? We need to measure and walk that in responsibly and conscientiously from my perspective, and that's what I mean by specificity from the law enforcement mission set. We need to do our due diligence to ensure that we're not incorporating bias into the information that we're collecting, which ultimately could be evidentiary. And we don't want to create complicated case law. So where AI can be used in our operations, I think it's going to be measured as in terms of application. But absolutely, I mean, it is a shiny object in the room, and man, we salivate over the potentials and possibilities, right? But just because we can do something doesn't mean we always need to jump in there and do it immediately.
Very good point. And I think you've both kind of given a nod to this, which is there's a lot of room on the spectrum between nothing but single user line of sight, single device, and fully automated AI driven flocks of drones doing all the surveillance along the border. Like there's places to to begin to look for automation or look for ways to filter the data that are those iterative steps, that one bite at a time.
No, absolutely. I mean, tracking, right?
Yep.
Automated tracking. I don't know if that's truly AI, but I've heard arguments for both. But I mentioned fleet monitoring, but counter, to kind of stump again what your previous speaker said. That's the thing that that's the thing that keeps us up at night, right? So the threat that we're seeing, the capability, our adversaries across the border, or the transnational narcotics or smuggling organizations, they're very well funded, and have access to everything that is conceivably sold on the internet. So very conscious of that, and we see that potentially whatever cognition engines that are running to provide better OPSEC or to give our folks so that our network of systems, right, has a sensor array or a capability to establish, oh wait, we're starting to be jammed and it's starting to intensify, or by the way, you've just been spoofed, kind of having that type of information, which we can't get right now, post mishap or post accident, post incident. That's very important because we want to build pattern of life of our adversaries. It's the intelligence part that provides us the intelligence of how to operate more effectively and efficiently.
Okay. And so I asked this question knowing that, unlike Peter, both of you can get in trouble for going too far down the useful fiction path. But I am sort of curious about sort of what you see in the near future. There's the way these are being deployed right now, and what you think are like good incremental advancements for your mission areas. And Michael, I'll start with you because you can talk about a lot of, recognize you're not the mission owner, but you see a lot of the discussions about where these systems are being either put into deployment or put on the drawing board for the Air Force and Space Force.
Yeah, certainly. So I'll start at kind of the tactical level, right? What we see today in Ukraine, what it sounds like Quinn is talking about at the border, these are relatively small, relatively short range, right? We're still talking kilometers of range, but what we in the DoD are focused on is certainly in the Pacific. There's a whole lot of ocean between the spots of land that we're interested in, that we are interested in avoiding conflict over, but still trying to manage interests around there. So, right, I want to be able to get from point to point, and so if we can extend range, right, that is a step in the right direction. It's not the be-all, end-all. There's some good papers out from CSET, right, where I'm doing my fellowship, about the limitations of onboard AI, or even just onboard autonomy, right? Vehicles that are relatively small, are relatively low-powered, don't have the compute power to do certain levels of algorithms, right? If I have to run it in a data center, it's probably not going to run very well on a remotely piloted aircraft that weighs like 5 pounds. So being able to push technology a little bit to push that technology boundary for some reason, right? If I just need a little extra compute to improve an image recognition algorithm, pushing forward in that direction might be useful for people. The other thing is just talk to the operators and see what they want. Now you have to be careful, right? They're going to have their very tactical view, but rightly so. They're the ones who are going to suffer the consequences or the benefits of it. Then if you can step back and look at the strategists and see, okay, exactly what's the big picture? And then, right, we've talked about the policy, the responsible use, whether it's for constitutional reasons, whether it's for the things that, well, we're all worried about constitutional reasons, right? But CBP has a very different set of reasons for why they're doing things, right? They're focused on the homeland. The DoD is focused on the homeland, but from an outside looking in perspective, right? So we end up in the same place for different reasons, right? We still want responsible AI, but if you can't have a system running AI, or even at some level of advanced autonomy because there's just not enough compute, or there's not enough power, or you just can't get it to where you want you can't get it to the fight, you can't get it to what you're trying to look at, then it's not relevant, right? So some range, more power, that's at the very tactical
Okay,
view, though.
okay. And Quinn, what about you? And I recognize that you've been in your current role for a relatively short time, but this is not a new space to you. Where do you want to see push for those incremental improvements, particularly with the point you made about the magic that's happening when you can get personnel to communicate more effectively with the people a quarter mile to their left or 2 miles to their right?
Well, I think that's two different. Well, that part, I would say.
You give the Washington answer. You answer.
Yeah,
what you want.
no. I would say that second part of your question was a bit of that overload. That's my ham-handed kind of response to what overload looks like at a tactical level. Best laid plans of mice and men, as soon as the first round goes down range, it's not really relevant. And that's what do you want to train to? What do you want to culturalize your folks to? And it should be, if you're going to put them in violent situations, obviously you want it to be somewhat simplistic. And then you don't want to overload. It should be. It's not. I know it's not the purpose is to take some of that off of it. But where to go in the future, we definitely look towards greater integration, and so that we can use some of the benefits of autonomy to provide better health and welfare for our fleet, which is a significant increase or enhancement to airspace safety, not just officer safety. Obviously, we like better sensor capabilities, better payloads, the farther reaching camera. We see, but endurance is the key. I had a guy tell me yesterday, as a matter of fact, we filled 9 different platforms as part of our deployment strategy, and we're rolling one out here this week, first class. And I was asking one of our seasoned pilots what he thought about it. And he's like, I like it because I can turn the camera backwards because my battery's getting ready to die and I need to fly home, I can still work the group. So he's squeezing out every half second he can. So, I mean, that's 10 more minutes, man.
I mean, that's a great example of, because the more range, more endurance, seems like a pretty obvious place to keep pushing on the hardware boundaries. But that kind of very functional thing, be able to film from your rearview mirror while doing this is important. So let's stay with this, the kind of technical limitations and what, to use your phrase, Michael, like what dials you want to be kind of adjusting on this. Where, if you were going to, give advice to the industry people in the room, you're like, where should the focus be on improving next year's model?
Small question, I know. So really, it's going to depend on the mission application, right?
Sure.
The DoD's not going to have the same requirements that CBP has, right? So they are going to be the experts in their area. As throughout my career as a tester, I hate to kind of pull up the Office Space reference, but I'm used to talking to the engineers and talking to the operators and trying to translate between the two. And so getting in that loop so that you understand, what can the engineers offer? What are the different dials they can turn? And I know I keep being a little generic on, what are the dials to turn, but having that conversation with the operators as well as the kind of the operational planners who are going to use these systems, have those conversations. If there's anyone here who can try to set up those dialogues, I mean, this is a decent one, that's a good place to have them.
And that may be a better way to ask the question of, like, how do you translate the mission needs to that kind of, the hardware and software functionality limits? How, I mean, the 180-degree camera wouldn't have necessarily been the top feature until you talked to someone about that use case. How, how can you do that translation and make sure that the right conversations are happening?
Yeah, a lot of it's about get it into an environment where you can test it. That's one of the reasons that Ukraine and Russia, honestly, have that really fast integration, that fast refresh cycle, right? They're motivated to do it, and they have a chance to test it in the field. Within the UAS, right, we set up these developmental test and operational test environments so that we can go try something out. Yeah. You can get the feedback that says, hey, what if there wasn't just a hard stop on the camera? What if it could look backwards? Right, that's where a lot of the conversations come out. And so within the government, right, it's a slow, it's a DR or suggestion process. Within industry, right, some of those are just conversations to have with the people in uniform, people who aren't always wearing uniforms, right, have those conversations and then try them out. And trust me, the operators will give you feedback and they'll say, hey, what if it could do this? Or that's dumb, don't do that. Usually listen to them.
Yeah. And Quinn, do you have, I mean, obviously you're talking to your personnel about this. Do you have kind of processes in place to make sure that feedback's coming back and informing, the strategic decisions CBP is going to make about where they invest and how, and even up to, delivering that feedback back to the operators?
We do. Like I mentioned earlier, I mean, it's all derived. The impetus for that is based on the field requirement, which we solicit directly from the various locations and then kind of consolidate, distill that as it comes up, right? It includes several different mission categories, different operating environments. But yes, it starts, for us, it starts at the ground level. I mean, there's constraints about, technology is going to move faster than policy
Right.
is in the United States, CONUS. So that's one major difference between perhaps DOD and DHS. So they're going to take advantage of the time, the expedited time window in that regard. But so we have constraints, we already know from a policy standpoint, from FAA standpoint. So we give that to the field, those constraints, and then let them tell us what they need, and then we go and dialogue. We dialogue with industry, and we've got an entire section of our team dedicated to making contact and keeping the pulse on industry. Where are they going? Military partners, DOJ partners, foreign partners.
And I will make the comments. You don't have to, Michael. We do know that DoD will listen to what Congress says, but I think it's fair to say there's a different balance of power in the conversation than there might be for certain domestic agencies. You mentioned, starting with the field requirements. What are the field requirements that you need most right now beyond the obvious of a battery that's half the weight and twice the power? You mentioned the policy side, but let's stay with the technology for a second. Is it about the device itself? Is it about the communications bandwidth? What are the other things that are kind of bubbling to the top of the wish list for CBP?
Not to speak with specificity, but the very first thing that comes to my mind is reliability. I mean, if we're trying to inculcate this capability, right, as something that's reliable, that's something that we plan to, we train to, that we deploy with a high degree or level of confidence. Mm-hmm. It's got to be reliable. We've got to be able to pair when it's needed to be paired, and so on and so forth. The safeguard, the fail safes have to work. Those kinds of things. That's not seeing that from a lot mm-hmm. of the assets that are available in the marketplace. Some folks are doing it a lot better than others, but that's what we're looking at right now. The capability to the policy is kind of where it can be. We're always looking, to gain an edge there, obviously, but right now we're looking for, good faith partnership with industry that provides customer service, reliability, standardized product mm-hmm. Across. Maybe they have multiple platforms, but the GUI and those kinds of things.
Mm-hmm. Mm-hmm. Michael, anything you want to add there about the field requirements?
Yeah, absolutely. So, absolutely hear you on reliability, and I want to turn it a little bit. So there's a certain level of reliability that you want for certain types of systems, and there's some you're willing to accept a lot lower reliability. If I think about this from a large acquisition approach, right, the war in Ukraine would be very different if Javelins and Stinger missiles were just demos and not something that the United States had invested a lot of time and effort into making sure that they worked, right? That's one end of the spectrum of making sure that you have very specific military capabilities that work. And then at the other end, I'm not going to say it's something that works like 10% of the time, but something you're willing to accept a little bit of losses on, something you're willing to accept it might not always work, that might be a little more commercial derived, right? Trying to fill out that spectrum is likely useful, right? It takes a lot of investment for those things that will work, you know, with however many nines. If you can leverage the power that industry has, the investment that they have, right? Because the DoD is no longer, well, the US government is no longer the biggest spender on R&D in the United States, right? If you can kind of tweak and leverage all the investment that's coming from industry, well, you don't want to reinvent that, and you don't want to layer on top of requirements, right? And that's kind of what we hear from the Deputy Secretary, right? You want quantity. You want to take what industry has and multiply it, replicate it. There's going to be a spectrum of the capabilities you need.
Okay, very good. And I'm glad you mentioned the acquisition side of things. So there was a question an audience question that popped up earlier that we didn't get to about, you know, what are the acquisition challenges? And I mean that in the broadest sense, not just like where can you buy it or what the price is, but about how to do, you know, whether it's doing the scoping, whether it's supply chain concerns, like what, I guess maybe my question is, what's your take on the current acquisition landscape when it comes to these type of technologies? And are there constraints there that we need to be thinking about?
I think the DoD writ large, right, and again, speaking for myself, not officially here, is learning how to leverage that commercial power, to leverage that commercial innovation. I mean, we are certainly throwing a lot of organizations at it. In the space domain, the SDA is taking that approach, right? Can we field a lot of satellites very quickly?
Yep.
DIU is certainly, right, is part of the front door to Silicon Valley. You have a lot of other organizations which are trying to do the same thing, right? We try to be a learning organization, and I think we are learning on, you know, what are the right contract types? How can we do this without going through the big A acquisition process, right? You're still going to be under the same federal acquisition regulation. Well, maybe you will be a non-FAR acquisition. Okay, too in the weeds there. There may be faster ways to get the capabilities you want, right? Middle tier acquisition. And so, we're learning to use the tools we have. I'm going to stay out of any discussion on do we need more tools from Congress.
Sure.
I'm going to let my leadership handle that. But the tools we have, I think we're still learning how to use them, and I think we are making progress.
And Quentin, you know, anything from your experience in sort of building the current array of platforms that you have, are there friction points you run into in the acquisition strategy for this, aside from the obvious of more money would always be good?
Well, yeah, well, the competing priorities right now, obviously, Border Patrol's stretched pretty thin. Not just money, but personnel. So that I would say that localized, that would be my first take on it. But you know, the other part of it to go along with the acquisition process, because we have assuming similar rules with the DoD in terms of like cybersecurity standards and vetting and what does that look like? You know, we've made use of the DoD. Thanks for any of the folks that are here from DIU, the SRR and the blue ones, and then you know the tranche twos, and as we go on, and potentially the greens. And I would like to see some kind of standard, some kind of capability that the federal government provides for all of the the stakeholders, so that we can get through that process, and then which would open also potentially the door for different types of systems.
Right.
That kind of like expands the marketplace. So I think that's probably going to happen in the future because the demand will just start to bubble.
Well, and that kind of takes us back to a point you've made a couple times, which is, systems brings all sorts of potential, but there's a cost to getting there, and there are trade-offs. And is there a danger of getting too complicated and too integrated right now? Is there, do you find? We'll start with just CBP in particular. Is there an argument to be made for kind of keeping it somewhat siloed for the mission needs of today? I know siloed is a loaded word. I should find a different synonym. But
No. It's difficult to answer because manpower is the issue of the day. The manpower is the issue of the day for most all law enforcement organizations throughout the country. If we take a man out of the loop, then we are making progress theoretically, right? It's the common thought, and I would agree with that to some extent. So the integration into a COP or a system of systems and remote deployed aircraft, those are all going to be benefits and advantages in the future. Like I said, I still think we need to walk that in because we don't know what that means from a law enforcement perspective and all those downstream second and third order effects that will come to place. I mean, again, I hate to create bad case law. I mean, that's not good for the entirety of the community, or it complicates further integration of AI. We don't want to misstep in our process either. So,
okay. Michael, what's your take on how do you strike that balance between the potential that comes with with more automation, more integration, and kind of leveraging the humans more effectively in this, with the complexity that comes with all those systems?
So it comes down to the mission, right? There's certain system of systems that just have to be that way, right? You're not going to get the missile warning enterprise without your radars, your space-based infrared, without the C2 to handle all of that, with all the algorithms behind it. Trying to silo each of those, you're not going to get the surety, the confidence in the system that you want. Are there other activities that you could silo just to get it out to the field quickly? Certainly. There's a happy medium somewhere. It's going to depend on the mission. Within the kind of space acquisition, space engineering community, there's a kind of a tongue-in-cheek, but actually kind of true set of laws called Aiken's Laws of Spacecraft Design. And it says that anyone who claims that the optimum is somewhere at the extremes is probably wrong. In nature, the optimum is usually in the middle. And that's true here, right? If you try to integrate every single autonomous system under one command and control node, if you tried to do the same thing for space, I know we're trying, that's a big bite of the elephant you're trying to take all at once. At the same time, right, if you do have that integrated system, man, it just looks easy once it's all done. And that's, right, all the integrated systems of the past, they look great. It was so easy, because everyone who struggled through it is probably retired by now. And so, right, trying to glom everything together is probably not the right answer. Right. There are going to be certain mission-specific capabilities that, go silo it.
Okay. Very good. So again, I want to make sure that we leave time for the audience questions, and let's start in the room again before we go to the virtual. Questions that we have here for our panelists. Yes, sir. Always send Walker running to the other side of the room.
Hello, Julian Atencio from Los Alamos National Lab. In this morning's news on the national headlines, there was a little girl who was found in the swamps of Florida, an autistic girl that was located because of a helicopter and thermal imaging. So this bridging of technology, in this case a helicopter, but it could have been easily a drone as well. This bridging of technology between behavior and technology is always something that we're looking for. In other words, how do we get our people to be able to do their job better? Because they're already motivated. That's why they're there. But what are those pieces of emotion? Because there's nothing more emotional than for a first responder, and I'm sure there's a lot of first responders in this room, to get that call of, subject located, run this way to go find her. I mean, this news clip today showed these police officers in white uniforms in the swamp, trying to look for this little girl. So it's very rewarding when you can find something like that, because most of the time the story ends a different way. But getting back to our world, how do we bridge the behavior piece? How do we release that dopamine to get our workers to be able to do stuff in a better way with the use of drones? That's what we're trying to figure out now, because the technology is already there, but that doesn't mean they'll use it. Finding that emotional piece to get people to want to work, to be able to do their job better, is what we're always looking to identify.
Yeah, what I've found in my acquisition career, let's talk on the acquisition, the development side. People like to work on the new thing. If you're doing some bleeding edge technology, you're a whole lot more likely to get the A team than if you're just trying to reinvent the wheel. So from the development side, yeah, anytime you're pushing the envelope or you have something that really matters, I've had the fortune of having a lot of good acquisition leaders, and the skill they had was always identifying, this is the reason we're building the system. This is the national security reason. This is why, to protect the homeland, we need to develop the system for the warfighter. From the operator side, right? I think Quinn's going to have a better answer than me, but one of the things is just getting the people in the room who are smart on different capabilities, right? If you have someone who's good at infrared, if you have them talk with the helicopter guys or the remotely piloted aircraft guys, or heck, if you have an EOIR expert and you have a synthetic aperture radar expert, they are more than the sum of their parts. You're still going to have the struggle of, okay, if I have this EOIR image and I have this SAR image, who's asking for it? What are they going to get? So there's always going to be that translation challenge. As far as the more...
Well, I think we think we've kind of already answered that question in a different way. I think it's reliability. If you want to kind of instill specific behavior, it's training, it's muscle memory, it's a confidence that I have a high degree of reliability in my kit, that it's going to perform the way I was trained to use it, and it's going to be there when I need it. That's why I go back to something from your previous talk. I think miniaturization, actually, from not just a tactical standpoint, but just I think that's really what we're most interested in, because we could see this being not trained as a specific niche capability within our agency. Maybe it's trained in basic training in the future, at the General Academy. And we're talking about the behavior becomes one and a part of conducting the mission as it's taught. So,
And I'm curious, part of that question could be interpreted as the cultural side of it, and this came up in the earlier session, but at CBP, are you seeing, are there places where you need to work to get the field personnel to kind of rethink their mission and embrace this? Is there the equivalent of the Air Force being in love with the heavily staffed flight squadron model, or wanting to make robotic tanks because that's what looks familiar? Or, my sense is that CBP, they tend to be leaning in and wanting more of these tools.
We're definitely holding reins right now.
Yeah.
So as tight and as hard as we can in terms of what from our user community perspective. The difficulty, I'm going to get in trouble now, but the difficulty has been executive buy-in to some extent, and talking about, integrating this new type of capability and that old regimental sense.
Yep.
Going back to the previous conversation. That's not just the fiscal investment that associates, but the changes to potentially doctrine, but also management. Management of our forces and the deployment and the lay down and what that means. So, not from the field level.
Yep.
Nope.
Okay.
And I know from the DoD side, right? Let's talk about the say collaborative combat aircraft.
Yep.
Without going into too much detail, right? We don't know exactly what that's going to look like when all is said and done. And so I think there's a lot of experimentation and thought being put into how you're going to organize the squadron, right? Whether, you call it, you're probably going to call it a squadron, no matter how much it changes,
Right.
just because, well, you're probably going to have someone or some grouping to manage those aircraft. And if they are teamed with piloted aircraft, so be it, right? That's how it's going to be organized. So as we learn more about the systems, you're also going to have to learn more about how the organizations are going to fall out of that.
Good. So I think we have time for maybe one more quick question before I invite Mark Valentine back up to the stage. But any others? Yes, sir, here at the front table.
How you doing? Jason Machado, I'm with DITRA. Specifically for CBP, if you could elaborate a little further on how you're thinking, kind of at the big picture level, about countering UAS threats and limiting your vulnerabilities and guarding against threats.
I'm going to deflect to some extent. I'm the offense, not offensive like carrying munitions offensive. I'm the offensive side of the squad. The defensive side of the squad will probably give you, and I can get you in contact with those folks. I'll definitely do that. But I think it's a question better answered by them in terms of vision, strategy, status, next steps. I know they'd probably like to talk to you. So.
Good. And I'm going to squeeze in one more from our virtual audience. And it's a question about interoperability, which mentioned, but this is being framed in between the device, the actual flying components, the controllers, the payloads. Is there is interoperability and kind of component swappability something that is a knob we need to be dialing in?
All things being equal, absolutely, right? There's a lot of scar tissue from, say, the space domain about trying to have universal payload interfaces. We're making progress in that direction, but it's always hard because that means you're not optimizing for one situation. And if you say, if range is the be-all, end-all, well, maybe you just can't accept the extra half a pound or pound of payload you lose. In the aggregate, absolutely. It is much more helpful to have plug-and-play payloads or at least quickly hot swappable ones. So yes,
And
if you can simplify
you've
it.
got nine platforms, I think you said. Is trying to bring more?
We've got 9 operationalized. We've got probably about a dozen, several test articles in play currently. But modularity, absolutely. And even if there are trade-offs, the utility of that modular concept would pay dividends. We don't really. We give a lot of briefs and to foreign partners that come and we'll sit down and say, hey, how do you organize your drone operations, your drone program? And the very first thing we tell them is, do not buy a drone and try and make it do what you want it to do. Buy a drone that's made to do what it does and use it that way. And that's just because there's been a kind of a lack of modular, but we definitely would love to be able to see that. I don't know that it'll ever be a one-size-fits-all for all of the mission sets and categories, but wherever we can find that efficiency, absolutely. That's, it's just good business.
Well, I think we are going to need to leave it there, but gentlemen, thank you both. I really appreciate the time and the from the ground perspective that you all bring to this. Thank you very much. Really appreciate it.